Hello friends, I am Dr. Nitin Kumar Saxena. In this video lecture, we will discuss the concept of resistance. If we have number of resistances connected in a circuit, how can we find the value of equivalent resistance for the simple cases? And like we see sometimes what happens, circuit is more complicated and in such cases it is very tough to find the equivalent resistance. So what can we do as a general procedure? So let us have a look. Suppose I am saying that in a circuit you have resistance R1. So if you see these two circuits in which I am showing only the two resistances R1 R2 which are connected in series, and second circuit R1 R2 are connected in parallel. So you see here, if this arrangement is connected with a voltage source V, so what will happen here in first case, if you see the current I starts to flow from this voltage source, the current will be same in both the resistances. So here we will say the current in this resistance is I, also the current is in resistance is I. So naturally the voltage across this is given by IR1 and voltage across this is given by IR2. Right. For this circuit, if you see, when current is going in this circuit, so what will happen? At this point, there is two branches. One branch is R1 side and one is R2. So here what will happen? This total current will be divided. Right? And if you see, these two terminals are same as these two terminals and as these two terminals. So what does it mean? This means that either say this A or this A or this A, all are same, because these all are the resistance free lines. And resistance free means, what does it mean? That if I move from this point to any point, these all points are equipotential. And since these points are equipotential, in the same way I can say to this side also, negative side, you see all these points are equipotential. Suppose I am saying B, so all these points are B, because all these points are equipotential. And hence, what can I conclude? I can conclude that if the voltage across AB is B, so the same voltage will appear across this, and same voltage will cross with this, because all our points AB, AB, AB practically are same. And hence what can I say here? Here I can say yes, I1 is V upon R1 because V is IR1 and I2 is V upon R2. This is fine. Now you see here, if I see the voltage is given by the formula, the voltage is given by the formula V is for this circuit is given by V1 plus V2. So what does it mean? What is the value of B? If I am saying the total circuit can be, the total circuit can be defined by an equivalent circuit R equivalent. In similar way, if I am saying total resistance of the circuit can be defined as equivalent circuit, so this means this V will be what? The current I and the total equivalent circuit. So I are equivalent. And hence IR equivalent as, put the value of V1 and V2. So IR1, IR2. So when you will solve, this I will cancel out from both the sides. So what you will get? Okay. In the same way, if I move to this circuit, so what I will say? The current AI is going from this point and distributing I1 and I2. So this means I is equals to I1 plus I2. Right? What is the value? Same way I can write here also. I is, if I am saying this is R equivalent, so I is VR equivalent. So V upon R equivalent is given by V upon R1 plus the value of I2 is V upon R2, and hence 1 upon R equivalent is 1 upon R1 plus R2. Right? And hence we can say that if resistances are connected in series, then total resistance or equivalent resistance is given by the sum of individual resistance. While if resistances are connected in parallel, the resistance can be given by this formula. Okay, and the important thing is, if I want to conclude these derivations, so I can say that for series circuit, for series connected resistances, number one, if resistances are connected in series, number one, as I have seen through this figure, that all the resistance have the same value of current while potentials are dropped in each resistance. So what can I conclude? The current in all resistances are same. And hence, if I have a circuit and I have to estimate that whether the resistances are connected in series or parallel. So what I will do, I'll check whether the current is same in all the resistance or not. If the current is same, this means these resistances are in series. In the same way, for the second concept, for parallel connected resistances, what will happen? First point, voltage in all resistances are same, right? Voltage in all resistances are same. The formula is given here for getting equivalent resistance as right, while the formula in parallel circuit is given by if I am saying we have number of resistances, then we can write like this. N resistances are connected in parallel. In the same way, if N resistance are connected in series, then this is the formula. Okay, now see the third point, which is very important point and conceptual point also. Suppose if I am saying R1 is 10 and R2 is 20, right? So what is R equivalent in first case? 10 plus 20. This is 30. While in second case, if you solve, Okay, so this means if you see here, means if resistances are connected in series, then the overall resistance is more than the highest value. Okay, so R equivalent will be more than the maximum of R1, R2 and Rn. Right? So if you have, suppose I have two resistance, one is 10 and another is 20. So when I am connected in series, so overall resistance will be more than the value of the highest resistance. So this is what I am saying. The maximum of R1, R2, R3, say, like it will be more than this. Right? In the same way, you see the value is 10 and this is 20. So equivalent resistance is less than the minimum value of the resistance. So what I can conclude, I can write the third point here, that R equivalent in parallel is less than the minimum value Okay, so mathematically I am writing this, or theoretically I can say that if I have number of resistances connected in series, then the equivalent resistance will be more than the value of the highest resistance. And similarly, if resistances are connected in parallel, then the overall resistance, equivalent resistance, will be less than the minimum value of the resistance connected in parallel. So this, if suppose I am saying, okay, I have resistance 10, 20, 30, 40, 50, right? And equivalent resistance is suppose 5. So naturally, this means the value of 5 is less than the minimum value. So this means resistance are in parallel, right? Since I am not sure about the exact value, suppose I am saying when I will solve, it is coming to x, right? And the question is that if I am connecting 10, 20, 30, 40, 50 in some circuit, either series or parallel, so the final value is less than the minimum value of 10, or less, the value is minimum to the 10. So whether the resistance are connected in series or parallel, is it fine? So in this way, since x is less than 10, hence it is connected in parallel. And if x is more than 50, then it is connected in series. Right? So I hope this concept is clear to you. Now the question comes, if I have a special kind of circuit in which the resistances are connected in star or delta. Suppose I am saying I have three resistances connected like this. Okay. The other connection right? Suppose I am saying this is R1, R2, R3, R3, R2, R1. So if you see this figure, what you will get? You will get here three resistances are connected in this way. Here three resistances are connected in this way. This connection is called delta connection, while this connection is called star connection. And the beauty is that if you have three resistances connected in delta, you can transfer it into star, and if resistances are connected in star, you can convert it into delta. Okay, So let's see how can we convert it. That means what if I know the value of R1, R2, R3, how can I get the value in terms of R1, R2, R3? And similarly, if I have the value in terms of R1, R2, R3 small, how can I convert it into delta? I'll give you one example also to see what are the advantage of changing delta into star or star into delta. That we will see later. But before that, we will see if I have suppose delta and I want to change it in star. In the same way, I can do reverse also. So if I am saying, okay, I have a circuit like this. Okay, so this is the circuit in which R1, R2, R3 are connected in delta. And what I want to change this delta into star. So changing to drive the formula, let us see the procedure which we can follow here. Suppose for changing the star, first of all we take a point at the center of this delta or triangle. Now connect this like this. Okay, connect this center from the vertices of this delta or triangle. Right? The resistance between R1 and R2 is just opposite to R3. So for the making some similarity, I am saying this resistance is R3. Similarly, in front of R2, resistance I am calling it a small r2. And similarly, in front of R1, resistance I am calling it small r. Right? So what I did, you see from this black marker, I am showing a delta, and from green marker, I am showing a star. And you see, like in any circuit, I can replace this with this or with this. Suppose I have a circuit like this. Okay. So what I can do? Suppose like this. 5 volt, this is 10, 20, 30. And this is what? Delta. And I want to change it in star. So what I can do? Okay. So this means in place of showing delta, I can show like star. Okay. What will be the value of these three? That we will see later. Right. So I hope the conversion is clear to you. Now see how can we find the values of these. So you see from this figure, okay, if I am giving the name like, I am saying this point is A, this point B, this point C. So for delta connection, find resistance between A and B. Okay, so focus on this black part only. So if you focus on the black part, so what I will get here, when you focus on this black part and you want to know the value of resistance between A and B, so I am writing it again, drawing it again. This is okay. So you see, if I want to know the resistance between this and this, so you see, whatever the current will go in this, the same current will come here. And I told you that if the same current is flowing in two resistors, these resistances are in series. And hence R1 and R3 are in series. So what I can do, in place of R1 and R3, sorry, I can replace like this, and the value of this is R1 plus R3. Now again you see, if I am saying, I am assuming that okay, current I is flowing like this, so what will happen? The current will distribute in these two circuits, while the voltage across these 2 points will be same, right? So this means this and this are in parallel. So what is the value of resistance. So 1 upon Rab is 1 upon R2 plus 1 upon R1 plus R3. This means R2, R1 plus R3. So you will get R1 plus R2 plus R3, and hence Rab is given by R2, R1 plus R3 divided by R1 plus R2 plus R3. Right. So this means I can write, hence I can write like the value of Rab can be given as R2, R1 plus R3 upon R1 plus R2 plus R3. Suppose I am saying this is equation number 1. Right? Now the same I am doing for star connected circuit. For star connection, what I will get, again I am doing the same thing. I am trying to find the value of resistance between A and B using star circuit. So if you see star circuit, again what you will get, the circuit is like this. This is A, this is B, this is R1, this is R2, this is R3. Okay, so you see, if I am supposing current is going like this, so current will come like this at this point. What will happen at this point? This branch is open. This branch is open. So if this branch is open, this means the current will not flow in open branch, because in my previous lectures I have told you that whenever we are applying any Kirchhoff's current law, so like the current will not flow in open circuit, open branch circuit, right? So this means if current is going here and this circuit is open, so no current will go there, and hence the current will go like this and same current come like this. And hence if the same current is flowing from this way to this way, there is no current is going. So this means since same current is in R1 and R3, so this means R1 and R3 in series, and hence Rab is R1 plus R3. Right? So what I get? I get R1 plus R3 upon, sorry, yes, what I get? R1 plus R3, equation number, right? So what we get? We get the total resistance, equivalent resistance between the point A and B when the resistances are connected in delta and when the resistances are connected in star. And I said that we can convert either delta into star or star to delta. This means these two circuits are equivalent. They have the same impact on the circuit, and hence if the Rab due to delta is this and Rab due to star is this is only possible only when these two values are equal. And hence what I can say that this both the circuit star and delta are equivalent since both the circuits delta and star are equivalent This means RAB from delta and star connection will be same. Okay, so this means if delta circuit and star connected are same, so the value which we get from delta connection and from star connection, they both should be equal, and hence if I am writing this way, so what I get, R1 plus R3 is R2 R1 plus R3 divided by R1 plus R2 plus R3. Equation number 1. So finally I get a relation between the small r and capital R. The small r means when resistances are connected in star. Capital R means when resistances are connected in delta. In the same way, if I use of similarly, if this is R1 plus R3, so I can write R1 plus R2 also and R2 plus R3 also. So you see, when there are R1 and R3, so in bracket we have R1 and R3. So if we have R1 and R2, so what we have in bracket? Capital R1 plus capital R2. The rest third is multiplied here. So what is rest? R3. And in denominator we have the sum of all the three. So from this equation we can correlate. Similarly we can write here also there is R2 and R3. So what will be in bracket? R2 plus R3. What is rest? R1. What is here? R1 plus R2 plus R3. And hence, in this way, we see we can get the three equations with having relations of resistances in delta and star. Now, if I solve these equations, I can get the value of small r1, small r2, small r3. Also, I can get the value of capital R1, capital R2 and capital R3. So, when you will solve, you can follow the mathematical steps, and mathematical steps I am not showing here. Simply you can add all these three, and when you will, after getting adding all these three, you will get a fourth equation, and from fourth equation one by one you subtract these equations and you will get the separate value of small r1, small r2 and small r3. Once you know the value of small r1, small r2 and small r3, and after again if you go in advanced mathematics you can get the value of r1, r2 and r3. So I am limiting myself in the derivation of getting these values, and I am directly giving you the answer, and for detail you can go for the solution of mathematics. Okay, so the answer will be here, small r1 can be written as r2 r3 divided by r1 plus r2 plus r3. So to keep in mind, how can we write the value of R1? So you see here, R1 is in between R2 and R3. So how will you write? R1 is R2 R3 upon the sum of all three. Similarly, the value of R2 is between R1 and R3. So R1 R3 upon R1 plus R2 plus R3. And similarly, R3 is between R1 and R2. So R1 R2 upon R1 plus R2 plus R3. So what do these results show? These result shows if you have the value of delta connected resistance, you can convert it into star, right? In a same way, I can write the values in terms of R1, R2, R3 for capital R1, capital R2 and capital R3. So what will be these values? So for writing this, the values will be capital R1 is given by R2 plus R3 plus R2 R3 upon R1. So how can we remember this? This value, if you want this value, like you have a star, and from this star, what do you want? You want delta. From this star, you want delta. So this R1 is connected with small r2 and small r3. So what you will do? This plus this into this upon this. So this r2 plus r3 plus the multiplication of this and this r2 r3 divided by the rest one r. And hence similarly, what is r2? R2 is connected with R3 and R1. So R1 plus R3 plus the multiplication of both divided by the third resistance. Similarly, R3 is connected with R1 and R2. So R1, R2, R1, R2 upon R3. So I hope the concept of star to delta and delta to star is clear to you, that if you have the circuit like delta, you can convert it into star, and if you have star, then you can convert it into delta. So I am giving you a very simple problem. The problem will help you to understand the concept of conversion from star to delta or this delta to star will be more clear to you. Okay, so let's have an example. Let's have an example. Suppose I am saying that, okay, okay. So this is the circuit in which the question is 1, 2, 3, 4, 5, 6 or 1, 2, 3, 4, 5, 6 resistances are connected in this way. The whole circuit is connected with 5-volt battery. So find number 1, find equivalent resistance across 5-volt voltage source. Second, find the current drawn from voltage source into this circuit. Okay, so what is the question? Question is number 1, for this circuit, find the equivalent circuit across the voltage terminal, means across these 2 points, right? Across these 2 points. And second, when we know the resistance across these 2 points, simply we have voltage, we have resistance, we can divide and we can get the value of resistance. So if you see, what is the concept? I told you that if current is same, the resistances are in series. If current is dividing, the resistances are in parallel. If I start from here, you see, at this point, current will divide here, here, here. Here, the current will also divide here and here. The current coming here will also divide here and here. And the current all is meeting here and finally coming here. So this is some complicated structure in which you cannot directly examine whether the resistances are in series or parallel. So first we check if we can use a simplest method by watching it whether the resistances are in series or parallel. If it is not followed, then we will go to the second step. What is the second step? Whether there is any connection like star or delta in it. So you see, you can check any circuit. Suppose I am checking this one. Okay. So for this circuit, you see this is a type of delta. Right? So if it is a type of delta, so what I will do, same thing, I will change this delta into star. How? I take a point here. From this point I will add this, from this point I will add this, and from this point I will add this. Okay, so what I did, for this delta, I have changed it with star. Now, since for simplicity I am taking all the resistances of 1 ohm, if you want you can change. Okay, so what is the value of this resistance? I told you this is in star, so 1, this is in between this and this. So what I told you, from delta to star, 1, yes, what is the value? 1 into 1 means this resistance into this resistance upon all these three resistance, 1 plus 1 plus 1. So what comes? 1 by 3. And hence, what can I say? The value of this resistance is 1 by 3. In the same way, the value of this resistance and this resistance will also be same because all the values are same. So, what I can do, I can change this circuit like this. Okay, for this delta, I can delete like this. And this will be your new circuit, right? And for this circuit, all these values are 1 upon 3, 1 upon 3, 1 upon 3. Is it fine? Now you see, if the current is, now again after doing this conversion from delta to star, now again I am saying, see, the current in 1 ohm and 1 by 3 ohm are same. What is the current here? The same will go in 1 by 3. This means 1 and 1 by 3 are in series. So what I can do, in place of 1 and 1 by 3, I can put simply 4 by 3 because they are in series. So what I can do? Right? Similarly, 1 and 1 by 3, again the same current is flowing in both. So these two are also in series, and 1 and 1 by 3 again will give you 4 by 3. Right? Now you see, next step, now you see 4 by 3 and 4 by 3. They are in parallel. Why? The current is dividing in both. You see, the current will divide, and is at this point, suppose I am saying, okay, if I am saying I is coming like this, here is I1, here is I2. So at this point, I1 will come again, I2 will come again. So what will be here? I1 plus I2, that is I. So you see, these 2 points are having the same current which is going in, coming out, and hence we can say 4 by 3 are in parallel. So if they are in parallel, so 1 upon R equivalent is 1 upon 4 by 3 plus 1 upon 4 by 3. This is 3 by 4, 3 by 4. 6 by 4. Okay, so 3 by 2, and R equivalent is 2 by 3. Right, so what I can do now, I can replace these two again with a single resistance value 2 by 3. Right, is it fine? Now you see again, this 2 by 3 and 1 by 3 again have the same current, which current is going here, the same current will go in 1 by 3. So 2 by 3 and 1 by 3 again are in series. So what I can do again? So 2 by 3 plus 1 by 3, both are in series. So what will come? So this resistance is 1, this is also 1. Now again you see, I1 is going there, I2 is going there, at this point I1, I2, so they I. This means in this loop, in this circuit, which having the two resistance 1 and 1, if current is distributing at this point, the same current is coming out, which is coming in from this point, and hence we can say 1 and 1 again are in parallel. And if they are in parallel, so what can I do? 1 upon R equivalent is 1 upon 1. 1 upon 1 means 2. So R equivalent is, and hence finally what I can do like this. Right. So what I see, I am drawing it again. My question I am drawing again. So I have seen that yes, so you see, in starting, this was your circuit, which is very complicated, complex in terms that you don't know whether the resistances are in series or parallel. But with the help of a star delta connection, you can convert this circuit easily in this circuit. And hence you can say between these 2 points or these 2 points, because these both points are same equipotential points, so what you can say, the resistance total for this circuit is 0.5 ohm, right? So the answer of first question is find equivalent resistance across 5 volt voltage source. The answer is 0.5 ohm. The second, find the current drawn from voltage source. So what is the current drawn? I is V upon R. So what is the value of V here? 5. What is the value of 0.5? So 50 upon 5 step. So the value of the current from this voltage source 5 volt in this resistance from here, or you can say here also, the current flowing from this will be 10 ampere in the whole circuit. Here 10 ampere in the whole circuit. And hence in this way we can solve any circuit easily with the help of star delta conversion. If we have delta, we can convert it in star. If we have star, so we can also convert it in delta. If you want to see, so you can see if for this delta, what can I do? I can make a star like this. Okay, now I can remove these 3. So what is the value of this resistance? This was connected with 1 ohm and 1 ohm. So 1 plus 1 into 1 upon 1. So what is this? 1 plus 1 into 1. So this is 3. Similarly, this is also 3. This is also 3. Right? So now this 3 and 1 are in parallel. So what can I do? I can change this with a single resistance. 1 and 3 in parallel means so our equivalent is 3 upon 4. So this is 3 by 4. Similarly, in the place of these two I can write 3 by 4, and similarly in place of these two we can write 3 by 4. Right? Now you see 3 by 4, 3 by 4 are in parallel. So what can I do? Oh sorry, 3 by 4 and 3 by 4 are in series because the same current is flowing in both. So what I can do? So 3 by 4 plus 3 by 4 will give you 6 by 4. Right? This is fine. So if this is 6 by 4, now you see 6 by 4 and 3 by 4 again are in parallel. So what is this? 1 upon. So I can write for these two resistances which are in parallel. So I can write 1 upon R equivalent as 1 upon 6 by 4 plus 1 upon 3 by 4. This means 4 upon 6, 4 upon 3. Take 6 LCM. 4 plus 3 2s are 6, 2 4s are 8, 12. So this is 12 upon 6. So what is our equivalent? 0.5. Right? So now I can do R equivalent is 0.5. So again you see the same you are getting R equivalent 0.5. So the same problem I have shown you that I can convert whether delta into star or star into delta. Right? In both the case the equivalent resistance comes same 0.5. So you have both the options. If you can change star into delta easily, change it. If you can change delta into star easily, change it and solve step by step. Okay, so I hope the conversion of delta and star, their formulae, their mathematical term relation, derivation is clear to you. Now the last point which is related with your equivalent resistance circuit, now you move in the next step. Next step, that we are not able to find whether the resistances are connected in series or parallel. And number two, we are not able to find the delta or star connection in it. So what can we do? Okay, so in this case, we see a most general method which is applicable to everywhere. Okay, if I want to find the resistance between the 2 points, suppose A and B, so first I will check whether they are connected in series or parallel. If I cannot find, no problem, I'll go to the second method. I'll see whether they are connected some part in star or some part in delta. If it is also not figure out, we cannot figure out whether they are in star or delta, so we will move to the third point, which is called the most general method and applicable to every case. The problem is this method is very long. It's a very lengthy process. Otherwise, this is the most general method. It can be used anywhere. Okay, so I'm giving you a very simple example. If it is you are able to understand this simple example, you can go for any generalized method, right? Suppose again I am saying I'm showing this method by for a very simple problem, though you can solve the value. If I'm saying this is okay 10, this is 10, this is 5, So what is the value of RAB? So you can simply find out that yes, 10 and 10 ohm are in parallel. So we will get the resultant of 10 and 10 ohm which are in parallel. So value is 5. 5 plus 5 because 5 is in series. So 10. So final answer will be 10. That we know. But I want to see the answer with the most generalized method. And this method is applicable for any type of problem. Does not matter how complicated it is. If the problem is more complicated, then what will happen? The number of the calculations will go more. Otherwise, it can be applied to any kind of problem for getting the value of RAB. So how can we do this? Simply in this method, we simply connect a voltage source between the point where we have to find the equivalent resistance. Since we have to find the equivalent resistance between A and B, so what we will do, we will simply connect a voltage source between the point A and B. And I am saying, for example, this is 1 volt. You can take any value of the voltage source. I am taking 1 volt battery, a 1 volt voltage source is connected between A and B. Right? Now, you start the concept which I have told you in the video class of KVL and KCL. You apply the concept of Kirchhoff's voltage law and Kirchhoff's current law that I have told you in my video related with Kirchhoff's voltage and current law. So what can I do? Suppose I current is going here. So I1 will go there, I2 will go there, and again I will come here. Right? So the polarity will be like this, because current always flows from higher potential to lower potential. If current is flowing this, so this is positive, negative. Current flows from higher potential to lower potential. Right? Take this loop. If you move in this loop, so what you will write? You write the KVL for this small loop. So what is this loop? Plus, because we are moving from plus to minus. What is the voltage here? 10I1. Okay. Minus, because I am moving from minus to plus, 10I2 equals to 0. Equals to 0. So 10I1 is 10I2. So I1 is I2, equation number 1. Now go in big loop like this. So when I am moving from a point A, so up to this point nothing. From this point, yes, what will come? We are moving from plus to minus, so plus 10I2. Now come here, plus to minus, so plus 5I, this is the voltage in this resistance. Come here, so what is the value? Minus 1 equals to 0. Right? So, what is I here? You know, 10I2 plus 5. What is I? I1 plus I2 equals to 1. I'm putting I is I1 plus I2. If you want, you can write it as another equation. What is this? I is I1 plus I2. You see, I is I1 plus I2. Right. Now, since I1 is I2, so what I am doing? 10I2 plus 5. This will be I1 plus I2. Both are equal. So 2. I2 equals to 1. So 10I2 plus 10I2 equals to 1. So I2 will be 1 upon 20. Similarly, I1 will be 1 upon 20. So, from this expression, what is the value of I? 1 upon 20 plus 1 upon 20, I1 plus I2. Solve this. 2 upon 20, so 1 upon 10. So, this means the value of I is 1 upon 10. So value of this I is 1 upon 10. Right? So simply by solving this circuit, we can find what is the current flowing from this voltage source in this circuit. Now you see, between A and B, the voltage is between A and B, the voltage is 1 volt. The current flowing in AB is 1 upon 10. So if I want to know RAB, so this is simply BAB divided by IAB. Right? Now put the values. Right? Which we have seen that the equivalent resistance between A and B is 10. So I hope the procedure is clear to you. I am repeating once again that if you want to know the resistance, equivalent resistance between any 2 points for any circuit, so what you will do first? First, you will connect a 1 volt voltage source between these 2 points and we'll see what current will flow from this voltage source into the given circuit. If you know the current value, since you know the voltage value, divide and you will get the final value of equivalent resistance. This is the most general method. This can be used for any problem in which we have to find the value of equivalent resistance. So I hope the concept of resistance in the circuit, when they are in series, when they are in parallel, when they have a special type of arrangement like a star and delta, and finally how can we find the value of resistance with the most generalized method. So these all points are clear to you. Thank you very much.